Welcome. Today I am going to discuss about of the questions that is related to pinnacle rearrangement and semi-pinnacle rearrangement if stereochemistry is mentioned. Okay, stereochemistry is mentioned in a group, and that is related to pinnacle. It means that what I want to discuss here today is that if stereochemistry is mentioned in a group, then how we will solve the questions that is related to pinnacle and pinnacle rearrangements. Questions related to Pinacolone rearrangements and semi-Pinacolone rearrangements. It means that if in a group stereochemistry is mentioned, then how we will tackle that type of problems. Let's say we have this type of questions here. Let's say we have these questions. Okay. And let's say here we have this OH is above sides, and this is that what you see that in for that semi-Pinacolone rearrangements, what is there? Semi-Pinacole rearrangements, what is that? In the two carbon atoms adjacent to two carbon atoms, one will be 2H, another will be that nitrogen gas, or like it may be chlorine, something like that. Okay, so at these two adjacent carbons, one is OH, another is let's say ammonia, or it may be that chlorine. Then this is the semi-Pinacole rearrangement, and let's say one group is here, and that is, let's say this is there. Okay, and now if you have that HNO2, then how we will solve the questions? In previous class what I have discussed, that this and this I have not mentioned the stereochemistry. Now if the stereochemistry is mentioned, then how we will solve these questions? That's what I'm going to discuss today. Okay, so what we know that this cyclohexane, this is actually exist in the chair form. So past for most of our work is to convert these cyclohexanes into the chair form, because whenever the stereochemistry is mentioned and if it is cyclohexane, then past work is to convert this into the chair form, because this is actually exist in the chair form. Then only we will solve the questions related to stereochemistry. So past will convert into chair form, because this cyclohexane is actually exist in the chair form. Okay, and how will we do that? So before that, note this, that actually I have already discussed these things. This is the chair form. What we have seen here, see, this is the axial positions. Okay, and this is the axial position. What are the straight things? Okay, this is the axial, and this is the axial, and this is the axial, and here this is the axial, and here this is the axial. So that what are the straight line. Okay, straight, that I can write here, straight hello lines are what? Axial. This is the axial positions. Okay, if any groups is there, let's say CH3, whatever the group, so they are in the axial positions. Okay, now that this type of things, this here, okay, and here this is like this, and here this is like this. See, that one is above and the other has to be down. Okay, this is down, then this is above. Axial is down, then this is the equatorial. Okay, this position is called equatorial. Okay, this is the downs, then equatorial is the above side, and this axial is above side, then equatorial with the downside, and this axial is the downside, then equatorial has to be the above side. So this pink line shows what? This is the equatorial positions. This shows that equatorial positions. Okay, so that's what this actually we should know that, and I think that I already discussed this thing, so we are very clearly know this. So this is the axial position, this is straight lines, the straight halo line. So straight halo line shows that axial positions, and this pink line shows that equatorial positions. Okay, and whenever we see that what is that in a carbon atoms, okay, this is the carbon, and that is that 4 carbon atoms is possible. One carbon can share that 4 carbon atoms. So this is already there in that rigid cyclic system. So one is above, then other has to be down. So this axial is in the above here, so that equatorial is down. Here that axial is the down, then equatorial is above. And here axial is in the above, so equatorial is down. Here axial is down, so equatorial is above. Here axial is above, so equatorial is down. Here axial is down, so equatorial is above. Okay, so this we has to clear, because why I'm saying this one. So whenever in a group is that this is, we know that this shows above and this shows the below. So whenever you say that this above sense, we has to put this one in the above side only. Okay? And whenever it shows that below, then we has to put that in below line only. That's why this is very important, that way this is above, this is below, and axial and equatorial position, that is also very important. Okay, and this is the point. And one more things, what we know that whenever you are converting any groups into the chair form, whenever you are converting any group in the chair form, always keep in the mind that 1,3 diaxial interactions should not be present. What I mean? Okay, so this is the groups. So let's say that the H atoms, this is not assumed as bulky groups, but except H, all other groups are assumed as a bulky groups. So remember that H is not assumed as a bulky groups, but that CS3, this is assumed as a bulky groups. Why I'm saying these things? So 1,3 diaxial interactions, it means that axial positions are this, and axial positions are this, axial positions are this, axial positions are this, and axial positions are this, and axial positions are this. So what I say that in this substituent, in this groups, that bulky group should not be present at 1 and 3 positions. This is the 1, let's say this is the 1, and this is 2, and this is the 3, and here also this is 1, this is 2, and this is the 3. It means that 1,3 diaxial interactions should not be present. 1,3 diaxial interactions should not present in the system. Okay, so it means that what I'm saying that at the 1 positions and at the 3 positions, 1 and 3, and this 1 and 3. So at 1 and 3 and 1 and 3, in this 1, 3, there should not be a bulky group. It means that here suppose we have that CS3, and suppose here also we have that CS3, then there will be the 1,3 diaxial interactions, and this is not stable. So this type of chair form we can't form. If one is CS3 at this axial and other at the 3 positions should be hydrogen, then there will be no chance of 1,3 diaxial, because H is not assumed as a bulky groups. It means that bulky groups should not be present at 1, 3 positions. That bulky group should not present at the 1, 3 positions. Okay, bulky group should not be present at axial positions in 1, 3, in 1, 3 relations, either here. So if H is present, it's fine. One is bulky and other is not bulky, then it's fine. Okay, either here or here. Also if C is present, then also that 1,3 diaxial interaction will happen. So here also should not be present that bulky group, here also should present H, then it's fine. Okay, that's what it means, that 1,3 diaxial interactions should not present in the systems at 1 and 3, 1 and 3. It may be this 1, 2 and 3. Okay, anyway, that this 1, this is 2, this 3. So these positions CS3 and these positions, should be H, should not be like CH3, that type of groups. If it is present, then that chair form is not possible, that will be not exist. Okay, so these things we should remember, that whenever you are converting these cyclohexanes to the chair form, always keep in that that should not be 1,3 diagen interactions. Okay, and better that what you will do, that always try to keep bulky group at equatorial positions. So actually that bulky groups, always try to keep that in equatorial position, so that there should not be a 1,3 diagen interactions. That is the one point. And we should do the correct mention, that if it is above, that with here which is the down, so whenever you are converting into the chair form, so keep in mind that that OH should be in the downside only. Okay, so that means that these things also should keep in mind. Correct correct order of substituent should be placed while converting cyclohexane form to chair form. It means that whether here that cyclohexane is there, and here that chair form. So if that here substituent is above, then here also we should keep that one in the above. Okay, and if it is substituent is below, then here also we should keep that one in the below. Means that correct order of the substituent should be placed while we are converting from the cyclohexane into chair form. Okay. So that things we should keep in mind wherever we are converting into that this cyclohexane into the chair form. And one more thing, that is okay, so these things we should keep in mind. And these groups, let's see it, this is this. Here what we have, that one we have that here this is a down, OH is there, and this is in the above NH2, and here we have that this group. Okay, so correct order of substituent means that what is that, name it 1 2 3 4 5 and 6. So that is going to be, I have converted into that, and let me name this 1 and 2 3 4 5 and 6. So see that this OH is the downside, so I will keep it in the downside here. Okay, because this is the down, and NH2 is the above side, so this is the above side, so I will keep that NH2 in the above side. 1 2 1 2. Okay, and 3 and 4 at the 4, this is the above side, so I will keep it in the above side. So this is the what I mean this point. Okay, so that is that correct order of the substituent should be kept while you are converting from cyclohexane to chair form. And one more thing, that what you see in here, this is the carbon atoms, and this is another carbon atoms. This is one carbon atom, this is another carbon atoms. So here this carbon atoms, and here that reagent is HNO2. So what you see, that this HNO2, the work is this HNO2, the work is that it will convert this NH2 into the nitrogen gas. Yes, that is convert into the nitrogen gas. This is the OH, and this is going to convert into the nitrogen gas into plus. Okay, this is that like this. Now what will happen that you see this carbon is one side is this, other side is this. It means that this is the other side, the one carbon has 4 atoms. Okay, one is this, another is this, and other side is OH, and other has to be H. It means that this is the 2-degree carbocation. Okay, and this 2-degree carbocation, and this is also 2-degree carbocation. So what we see that we've seen that SN2 reactions, and we have also seen about that SN1 reactions. Why I'm talking about of this SN1 SN2 reactions? See here, this has that anti-bonding is this sides. Okay, and it's so what we see in that SN2 reactions, what we have seen, this is the 2-degree carbocations, and this has to be to that. This is the 2-degree carbocations. So what I have seen that for SN2 reactions, 1-degree carbocations. Okay, then this is always prepared to the SN2 reactions. And if it is 3-degree carbocations, then this always prepare that SN1 reactions. That's we know. And if it is a 2-degree carbocations, then it can do SN2 or SN1. Similarly, 2-degree carbocations that can do SN1 or SN2. It means whatever I say that whenever 1-degree carbocation, then always SN2 reactions. Okay, and whenever 3-degree carbocation, then always that SN2 reactions. For 2-degree carbocation, both chances are possible. So here what we have that this is the 2-degree carbocations. Okay, so 2-degree carbocation means it can be that SN2 or it can be the SN1. That's depend on that what the favorable conditions is. Okay, now what is the things about of SN2 reactions? So SN2 reaction is 1-degree carbocation. Let's say this is hydrogens, and let's say this is hydrogen, and let's say this is the hydrogen, and let's we have that chlorine atoms is there. Okay, now this is the leaving groups. Then what will have that, let's say that nucleophile is there, and this nucleophile for SN1 reaction, for SN2 reaction, this is about of that SN2 reactions, this nucleophile will attack in the back side, because this antibonding will be that side, pi star. So this will attack in the back side of leaving group. It means what we get that here hydrogen is there, here hydrogen is there, then that nucleophile will be this side. Okay, and here that hydrogen is there. So like that product we will get that. It means that what is saying that this nucleophile will attack in the back side. That's why you get that back side. So this is about of that non-cyclic systems. But if it is a cyclic system, let's say this is the rigid cyclic systems. So for a rigid cyclic systems, then what we will do that here also that if that is SN2 reactions, then there also that nucleophile should attack in the back side, because this is again that SN2 reactions. So let's say this case. Okay, now I'm talking about of this. Let's say here we have that N2 gas, and here we have that what is there, that is okay. Here we have that OH, and here we have that H. So this is again this is the 2-degree carbocations. Okay, and 2-degree carbocations, then what will happen that here SN2 reactions is also possible. So here that SN2 reactions will happen. Okay, now since this SN2 reaction is possible, so that attack will be always in the back sides. So this is the nitrogen gas, then that back side will be that it will have that anti-bonding is here, sigma star. So this is the back side of this nitrogen gas. Actually what we are doing here, this chlorine, that anti-bonding is there, and this nucleophile attack to the anti-bonding. That's why it will come to the back side. So similarly case, here nitrogen gas, then its antibonding will be in this directions. Here the antibonding, and antibonding then to this antibonding, whatever the parallel to this antibonding, that will attack here in the rigid cyclic systems. So that is about of that difference between that rigid cyclic system and this is the non-cyclic system. On that time we are attacking the backside, but in this time, since this is the rigid systems, so here this rotations will not happen because this is the rigid systems. So what will happen that whatever the groups that is parallel to the antibonding of this nitrogen gas, as antibonding of this nitrogen gas or whatever the leading groups, that will be attacked here. This is called that anti-periplanar relations. Periplanar relationship. It means antibonding of leaving group and bonding orbital of this, we can, let's say we talk about of this nucleophile, or you can say that migratory groups, because this is going to be a shift here, means this is going to attack here. Let's say migratory groups, bonding orbital of migrating group should be parallel to each other. Okay, so this is what it says, that anti-periplanar relationship means that antibonding of leaving groups, this is the leaving groups. Okay, so antibonding of the leaving groups and bonding orbital of migrating groups. So this is the this is the parallel to this. So this will be attack here. Okay, that whichever the groups, either here whichever the group that is which is parallel to this antibonding of this leaving group, that will attack. Okay, so bonding orbital of migrating groups should be parallel to each other, then only this will happen. Okay, so that's what I'm saying here. So two things can possible. Let's say leaving groups is at axial positions and leaving groups is at equatorial positions. So if leaving group is at axial, it means that what is said that leaving group is at axial. It means that leaving group is here. Leaving group is here, and here what I say that leaving group is at equatorial. So let's say leaving group is here. Okay, then for this case the antibonding will be this sides, and for this case antibonding is this sides. Okay, now you tell that for this the parallel will be the, this is the parallel to this one, so this will be this will attack here, and now this that to this the parallel will be these groups, whatever present in the, whatever the group present in this, that will attack here. Okay, so that's what we has to keep in mind, that if leaving group is in this directions, then antibonding will be here and this will attack here, and if leaving group is in the axial position, then this group, whatever the group is there, let's say H or maybe CH3, that will be attack here. Okay, so this is about of that concept about of that anti-periplanar relationship between anti-periplanar relationship between leaving group and migratory group. So whatever this group. Okay, so this is the that things. Okay, the leaving groups can be at the equatorial positions and can be at the axial positions. Then this type, this will be a migrant, and this is the possible if it is this carbocation is either 2 degree or 1 degree. Okay, only here that SN2 reactions is possible. So we will do this anti-peripheral relationship only if it is a 2 degree or 1 degree carbocation, because 2 degree and 1 degree carbocations only the SN2 reactions is possible. And if it is 3 degree carbocations, then we will not look about of this anti-peripheral relationship. On that case, SN1 reactions will happen. And in SN1 reactions, what you see that, let's say this is the 3 degree carbocations. Okay, so if that, let's say here we that leaving group is this, and let's say nucleophile will attack. So nucleophile will attack the same side of that leaving group. It means that is going to be like this. So here that anti-peripheral relationship is not important, because that nucleophile is attacking on the same side where the leaving group is live. So here we will look only the migratory aptitude. So if for SN1 reactions, I mean that is if 3 degree carbocation is there, then only look migratory aptitude. So that I will discuss whenever I am talking about of the examples. Okay. So these things we should keep in mind while solving the questions related to stereochemistry, if stereochemistry is mentioned. Okay. So I think up to this is clear. So where we will look that if SN if that is 1 degree or 2 degree, then we will look that anti-peripheral relationship, because on that time 2 degree that is SN2 reactions where that nucleophile will attack back side of that leaving groups. It means that in case of cyclic systems that it is a rigid system, so that here anti-peripheral systems will look, because this is a rigid systems. Okay, so now we will solve the questions that will clear more. So first questions will be this one. Okay, so first work is to convert into the this cyclic system into the chair form. So first convert into the chair form. Okay, and whatever that this is in the below, so put in the below. Okay, first name it. If you confuse, name it 1 2 3 4 5 and 6. 1 2 3 4 5 and 6, and O that is below sides, and 2 that is, this is the 2 adjacent carbon atom, one is OH, another is NH2. So this is the semi Pinacole rearrangements. Okay, semi Pinacolone rearrangement where stereochemistry is mentioned. So one is OH is that side, and NH2 is in the above side, so I will mention that one. This is the above side, so mention it in the above side. Okay, and at the core we have this, and this is also in the above side, so I will mention the above side. This I convert into a cyclic form into the chair form. Now what we have that HNO2 will be there, and HNO2 what it will do, that it will convert this NH2 into the N2 gas. So work of HNO2 is to convert this, I can make it work is to HNO2 work is to convert this NH2 into that N2 plus, and this is here OH, and this is like this. So now what we'll do, that this has that these things, and this is what that this is that 1 2, this is the 2 degree carbocations. So here that SN2 reactions is possible. So here what you look, that anti-peripheral system is looked. So here this is N2, so it is antibond is in this side. Okay, now what will happen, this, so what anti-peripheral relations means, that what is say that antibonding of leaving group and bonding orbital of migratory group should be parallel. It means that to this parallel is this group. So this will attack here. It means what we will got now. So name it. So if I name this one let's say this is 2, 3, this is 4, this is 5, this is 6. Oh. This is 1, and this is 2, this is 3, this is 4, this is 5, this is 6. Okay, so now what will happen, that this is going to attack here. It means that whatever how I will have to give them, that I have already explained whenever you are doing the ring. So this is attacking, it means this is negative, and this is going to leave, so this is going to be the positive charge, and if it is negative, then this is to be positive. Okay, so this positive, this will break, and this is going to fall. So what you will get here, this will happen. Okay, because this is going to break. So this is 2, this is 3, this is 4, and this is 2, 3, 4, and this is 5, and this is 6. Okay, so this is attack, and this is going to leave here. So nitrogen gas has left. This is going like that, and 2 and 1, this will break. 2 and 1 will break, and this is going to be that CH2, and here we have that OH. Okay, because wherever this positive, that will going to break, that I have already told, that a negative positive will make bonds, and this is going to break. Okay, so this will going to break. Yes, anything wrong? Okay, so not break. So this will make bonds, and this is going to break. This is going to break. Okay, so this 2, 1 has break, so that's why here no bond is there, and 6, 1, and this one is going to get positive charge, so make it in the positive charge. Okay, now what will happen? So in the pore, this is there, pore, and at the 6 we have this nitrogen gas, and that is come here, and at 1 we have that OH groups. Okay, it's fine now. Now what will happen, that here we have that electron, so this will donate here. So that's the same things whatever I have explained about the same Pinacole rearrangement, same this will donate, and that is going to be like this. Okay, this and this C, and this will donate. This is going to be so this is not this CH. This is not CH. Okay, so this is going to be that CO and H, and here we have that groups in the above side. So this is the final answers if stereochemistry. Now after that, convert into the again to that this one. So this is 5-member ring, so convert into the 5-member rings. Okay, and let's say this is 2, this is 4, this is 5, this is 6, and this is 1. So let's say this is 4. I can write 4, then this is going to be 5, this is going to be 6, and this is going to be 3, this is going to be 2. Okay, and 6 we have here, that is going to be the CO, H is there, and 4 I have this groups. Okay, so likewise we can solve the question. This is the final questions, final answers for these questions if stereochemistry is mentioned. So likewise we can solve. So if stereochemistry is mentioned, we have to solve like this. Okay, we have to convert into the chair form, and we have to do like this. Anti-peripheral systems we have to look that, otherwise that answer is going to get wrong. Okay, so likewise we have to solve, we have to convert into the chair form if stereochemistry is mentioned. Now moving to the next questions. this is the next question is. So moving to this next questions, again we have to convert into in the chair form. So convert it chair form, and here O is in the above side, so this is going to be this sides. Okay, and NH2, that is also, so this is again, this is 1 and 2, the two adjacent carbon atoms OH and NH2 is there. So this is the part of that semi Pinacolone rearrangements. Okay, so this is going to be the NH2, and here we have that this groups. So if you confuse it, just name it. Okay, here we have that HNO2. Now what will happen, this NH2 is to convert this NH2 into that nitrogen gas. So this is going to, so here we have that OH, and this is going to be that N2 positive, and here we have these groups. Now what will happen, so this, then here also that backbone, that is antibody will be here, and to this that we have to look the parallel. So this is the parallel, that is anti-periplan system, so this is going to attack here. So again the same things will happen, that is going to be here. I can name 1 2 3 4 5 and 6. Then this is going to be that this is attack here, it means that this is negative. After leave, this is going to be positive, so negative positive make bond, and if negative, then this is going to be the positive charge. So what I'm going to get here, okay, and so name 2 is attack here, so this is 2, and this is 3, and this is 4, and this is 5, and this is going to be 6, and 6 and 1, this bond has 6 and 1. So here we have that CH2, and this one is getting positive charge, so this is going to positive charge, then this going to be OH. Okay, so this is what it happened. Now what will happen, that at the core this group is there. Okay, so now what will happen, then again this will share it, so same things you will get. So this is going to be like this, and this is going to be that CO and H. So after that, convert into the 5 member rings, because this is 5 member ring, 1 2 3 4 5. So convert it, and what we have, that this is 1 2 3 4 and 5. So 5 that is having these groups, so I will make it COH, and at the 3 I have these groups that is in the above, so make this one. So this is the final answers for this question. So likewise we will solve it. First convert into the chair form and look that anti-periplan systems, after that solve it. Okay, and look that while you are doing this one, 1,3 diagonal interactions should not be present. It means this is 1 and 2, here 3, here should not be CH3, should not be other bulky groups. H is 5. Okay, like that, here and here also. In this and this, 1 3 and 1 3, 1 3 diagonal interactions should not be present. That we should keep in mind while converting these side reactions into the chair form. Now moving to the next questions. Again the same manner, convert it into the chair form. Okay, so this OH is in the now downsides, and NH2 is also in the downsides. Okay, and this is in the above sides. So now what will happen, that we are going to give that HNO2. So why I am doing here anti-periplanar systems, because here also you see that, okay, you see that this is the 2 degree carbocations, because after it will leaves here positive charge will form, and this is the 2 degree carbocation. That's why I am doing that anti-periplanar system. If it is, if here is CH3 is there, then this is the 3 degree carbocations. Here that anti-periplanar system will not happen, because 3 degree carbocations SN1 reactions will happen. Okay, on that times we will not look that anti-periplanar systems here, because this is the 2 degree carbocations. That's why I am doing that SN2 reactions. That's why anti-periplanar system is looked here. Okay, now the same things here. So this HNO2 will convert this NH2 into the nitrogen gas. Okay, So that is going to be that OH. This is again that adjacent carbon atoms OH and NH will be there. So this is semi-Pinacole rearrangement, and this is going to be that N2 plus. Okay, and this is going to be that groups. Now what will happen? You see that this is that again the 2-degree carbocations. Means after leaving this we will get the 2-degree carbocations. Okay, so if it 2-degree carbocation, then then that is SN2 reactions which happen. Okay, because this is the HNO2 is there, so SN2 reactions. So here to this the planar is this group is the that is parallel to this. That's why I've told that if leaving group is at equatorial, then what will happen? Leaving group is at axial, then which is the migratory aptitude. That I have told that. This one I have explained, right? This if leaving group is equatorial positions, then this will be the migratory groups. If the leaving group is at axial, then this is going to be the migrants. Okay. So that things. So this here hydrogen is there. Because nothing is there, then hydrogen is there, because one carbon make the 4 bonds. So one is this, then other is hydrogen. So this is going to shift here. So see that migratory groups will be either CH3 or H. It means the either here H is there or CH3 is there. Okay, so here H is there, so H will be do that. It means what will happen now? This is going to be, if H will shift here, then we will this is shifted to here. It means that here we will get the positive charge. So here I will get the positive charge. OH is there. Okay, and this nitrogen has group has left now, and that is going to be like this. Okay, so now that is remain as it is. Now this convert into the so now what happened, that this will give the electrons to here. So that is going to be this, and here we will have that double bond of, and here we will have that this things. So if you convert it, then this will be going to the 6-member ring. So if that leaving group is axial, then that will remain as the 6-member ring. If that leaving group is at equatorial, on that case that is going to convert into the 5-member rings. That's what I have seen here, right? If that leaving groups, this is going to be leaving groups, this N2 gas is N2 gas. Here that N2 gas was there. So if leaving group is at the equatorial, on that time it was converting into the 5-member rings, because this is going to the bond breaking is happening, so that's going to 5-member ring. But if the leaving group is at the axial, then that no bond break will happen, that this will going to migrate. It means that it will remain as a 6-member rings. Okay, and now what we'll see that okay, so this is going to be this, and this is, let's say 1 2 3 and 4. So 1 2 3 and 4. Here we have these groups. Okay, 1 2 3 and 4. So this is the answers for this question. So here no bond, 6-member ring remain as the 6-member rings. This has converted into these groups. For this case, this has converted into that 5-member ring. That is this one. One, two, three, 4. So this is going to be the answers. But this has converted into this is the answer. Okay, so 6-member ring has converted into the 5-member ring. Okay, so now moving to that next questions. This is again that we convert into that HNO2, and again we convert it into, first convert this into the chair form. Okay, NH2 is the above, so repeat NH2 in the above, and OH is in the down, so this is OH in the downs, and this is in the above. Okay, now we are giving that HNO2. So HNO2's work is to convert. So this is the again semi-pinnacle rearrangement. This adjacent carbon NH3 is there and OH is there. So this is going to convert into nitrogen gas. So this is going to be that N2 plus, and this is going to be the OH, and this is going to be like this. Now what will happen? You see that if it leak, then this is going to be 2 degree carbocations, and again that is going to be that this leaving group is at the where at that axial positions. It means that here what will happen, you see here to this, the parallel is this. Okay, so it means that antibonding is this sides, and this to that this is the parallel to this, means that antibonding of that leaving groups and the bonding of that migratory group should be parallel, means to this antibody this is the parallel group is there. So now that OH will not migrate, because OH, what we see that in case of Pinacole rearrangement or semi-Pinacole rearrangement, what we see that that OH should be stay here, because that OH whenever it will migrate, here positive charge will be there, and that positive charge is stabilized by that OH groups that we have seen in the semi-Pinacole rearrangement or Pinacole rearrangement. It means that OH we can't do the migrate, because this OH, the positive charge will be there, that will be stabilized by this OH, so we can't migrate the OH. So what will do that, here this lone pair will migrate here. Okay, so that's what you see that, and what you see that this OH is the downside, so downside attack will happen. It means, okay, here we have that O is there, and this is going to attack for this, means it is from the downside. From the downside it attack. Okay, after that this is going to be the like this. So whenever you make this into that cyclohexane form, then this is going to be that cyclohexane remain as it is, and this is 1, 2, 3 and 4. So let's say this is 1, 2, 3 and 4. So in the 4 we have these groups, and at 1 and 2, this 1 and 2, and this is in the from the downside. It means that this is going to be the, because this is attacking, the lone pair is attacking from here, it means from the downside it's attacked, so we can show that by this down. Okay, so this is the answers for this questions. So if for this, answer will be like this. Okay, likewise. Okay, moving to the next questions. After that we have some questions, couple of questions, then we will solve that. So again in these questions, first our work is to convert it into the chair form. So convert it. Convert into chair form, and this is OH is the above side, so I can mention OH above, and this is the down. Okay, this is the down. Okay, and this is that above. If you confuse, name it. Okay, and this is going to convert into HNO2, and HNO2 work is to convert this NH2 into the nitrogen gas. Or I am direct converting here. So this is going to convert it to the nitrogen gas. Okay, you will convert it. I am doing directly now because we have solved a lot of questions. Okay, now what will happen? This is the leaving groups, and that antibody is in these sides, and here this will go to attack it. And now this is in the above. Okay, OH is the above, so this is attacking from the above sides. So here what will solve that? Same things. So here that OH there, that is going to attack here, that is from the above sides. So whenever you do it, then this is going to be like this. So let's say this is 1, 2, 3 and 4. So 1, 2, 3 and 4. So here we have these groups, and 1 and 2, that is going to the above sides, because here what we see that this OH in the above, and this OH lone pair is attacking to the antibody of this living group. So from above it is attacking. That's why this OH are attacking from above. So that's why we need to write here in the above sides. Okay. So likewise, we will solve the questions. Now this is the next questions. In this question, directly given in the chair form. So if it is given in the chair form, so answer will be also in the chair form only. So we look the options accordingly. We will solve the we will choose the answers. So here what will happen? What we see here, 2 OH is there. Okay, this OH and this OH means this is the Pinacole rearrangement. Means adjacent carbon atoms 2 OH is there. It means that this is the question from Pinacole and Pinacolone rearrangement. Okay, so now which will attack to this H plus? So what is seen that which will attack, which is after without rearrangement, which is stable, that will attack. It means this is going to attack because here hydrogen is there. This is not stable, this is stable, so this is going to attack to this. So what will get here? So that I have told that OH will protonate, which will after that leaving that carbocation should be stable, so without any rearrangement. So this is more stable, so this will attack here. Okay, so that is going to be that OH is here and CH3 is here, and this is going to be the OH2 positive. So this is going to leave here. Okay, so this is going to convert this one. Okay, so this is the OH here, and this has left, so here we are getting that positive charge here, and here we have that CH3. Now what will happen? This is going to be that 3-degree carbocations. Okay, since this is the 3-degree carbocation, so here what will happen that okay, so where is the living groups? Okay, so this is the OH2 positive. It means that the living group is here. So to this is the 3-degree carbocations. So if 3-degree carbocations, on that case what will happen that this is anti-periplanar system will be not look. Anti-periplanar, because 3-degree carbocations, it means that this is going by SN1 reactions. SN1 reactions that will attack that. SN1 reactions, what I say is that nucleophile attack same side of living group. It means that we will here for 3-degree carbocations, anti-periplanar relations not look, so this will not apply here. Okay, so it means to this which will attack that. In this case what we look that for the SN1 reactions for 3-degree carbocations, we will look that migratory aptitudes. So now our migratory aptitude should be looked. Okay, so here this will be shift in this case. So which will shift? And here we have that hydrogens. So first will be that hydrogen, then phenyl, then alkyl group. So this will be shift. So what we'll get now? So here we will have that positive charge, and here we have that OH, and here we have that OH. Sorry, that is left. So here we get the positive charge, and here we have that H, and here we have that CH3. Okay, now after that this lone pair will share here, so you will get the answer is like this. So this is going to be the double bond. Okay, so here we are going to the double bond, and here we have that H, and here we have that CH3. So this is the final answers. If 3 digit carbocation is present, the 3 digit carbocation on SN1 reactions. SN1 reaction means we will not look that anti-peripheral system, that system that is not apply here, because this is go through SN1 reactions. Similarly, another questions we can solve this one, very interesting questions. Here also which will attack, so both are same, so anyone can do the protonesis. So what we'll get here, this is going to be the OH, this is going to be the CH3. Okay, this is going to be the positive charge now, and this is going to be CH3, this is going to be the OH. So now that migratory aptitude will look, because this is the 3 degree carbocations. Okay, 3 degree carbocation, then this will go by SN1 reactions. So SN1 reactions we will look about of that migratory aptitude. So for this, here which someone has to be shifted. So this is that what I see that first, that is hydrogen, then phenyl, then alkyl groups, and for alkyl groups what I see that 3 degree, then 2 degree, then 1 degree. Okay. Now this is the this CH3 is 1 degree, and this group, this is the 2 degree. So which will shift? This going to be shift here, because for R groups order, that is 3 degree, 2 degree, then 1 degree. So this is 1 degree, because CH3 means HH, HH, HH. This is going to be 1 degree, and this is going to, this groups is going to be that here is there, here is there. Okay, and H, H. So this is going to be the 2 degree carbocation. So this one to shift here. Okay, so if it is shift, then let it negative, let it be negative, and this is going to be positive, then this is going to be the positive charge. So negative positive make bond, it means, okay, this will happen, and this is going to break. So here what you see that here we have that here we get the positive charge, because this is going to break. So this is going to be CH3, and here we have that OH, and positive charge is there. Okay, and this is going to shift here, and what we get here, here we have that one is CH3 is there, and this leaving group will be leave. Okay, so this is going to be that this one. Okay, and now what will happen now, so this lone pair will give it, so that is going to be, this is going to be that CO CH3, and here also we have that CH3. Okay, so this is the final answers for this question. So likewise you can solve it. If it is 3 degree carbocation, on that time so we will look at migratory aptitude, not that it will shift, that this is going to shift here, this lone pair will shift here, that things we will not look, because this is the 3 degree carbocation. And 3 degree carbocation, on that time SN1 reactions will happen. See that 3 degree carbocations, it never happen that SN2 reactions. It means that anti-periplanar systems we will not look in this case. Okay, that is the good things for this questions. So answer is, this is the answers for this questions. Okay, that form 5 member. 3, 4 and 5. Okay, now solving to the last questions. So what is here, this is again that OH and OH is there. Okay, and which is more stable? Here phenyl is there, so this is going to be more stable, so this is going to attack here, this is going to do the proteinases. So here OH2 positive, and here we have that CH3, and here we have that phenyl, and here we have that OH, and here we have that CH2 CH3, and here we have that carbons, and hydrogen is there, and here we have that phenyls, and here we have that CH3. Now what will happen? this is going to shift. So this is going to form the carbocations, and this is CH3, and this is the phenyls, and this is that C, and here we have that OH, and here we have that CH2, CH3, and here we have that C, PH, and here we have that H, and here we have that CH3. So which will migrate? So in this case, which will migrate? Because this is the 3 degree carbocation, so migrate after 2 degree. Okay, so which will migrate? So this is that 2 degree carbocation, 3 degree carbocation. So we know that 3 degree is more than 2 degree, then 1 degree, so 3 degree will migrate here. And whenever you migrate, this group will remain intact, it will not change. Okay, whatever the stereochemistry of this group remain as it is. So it means what I want to say, this is C and this is C. Okay, here we have that OH, CH2, CH3, and this is going to positive charge, and this group has migrated here. Here we have that CH3, here we have that pH. So whatever the groups, that will same, stereochemistry of that group is same. Means here pH is like this, above, pH will above. Here H is in the plane, H will plane, and that is in the back side CH3, so that will remain as it. And now this lone pair will share here, so this is going to be the, okay. This is going to be the final answers. So what it means that here, so what I want to say in this question means whatever the stereochemistry of this group, whatever the migrating stereochemistry of this migrating group will remain as it is after migration also. Means this is remain as it is. Okay, means what I want to say, the stereochemistry of migrating group remain intact, remain unchanged. After migrations. Migration also. Okay, so that's what I want to say. It means that whatever the stereochemistry, that will remain as it is after migrations also. So this is about of the stereochemistry related to Pinacole and Pinacole rearrangement. We will discuss other name reactions related to carbohydrate in the next class. So today, after this, thank you.